So let's dive into the topic on solar panels. I'm excited to share a lot of information with you here. The first thing that I want to clarify and the first thing that I want to get out of the way is what the proper wording is, what the official correct wording is for solar panels. Because you might also come across the terms of photovoltaic modules, PV modules, or solar modules. Now, I'm often using the word solar panels, but this is not the correct phrase, the correct wording. The right word is photovoltaic modules or PV modules. These are the correct phrases that you should use. And again, I'm often using solar panels or solar modules. But now at least you know what the correct wording is. I've organized information in 4 main chapters. The first one, being the PV Tech, will look at all the different technologies that are available and the core operating principle of solar panels. The second one, Installation, will look at everything related to the installation procedure of solar panels. The third one, Configuration, will look at everything related to how you could set up your system, what kind of options you have, the pros and cons, and everything related to how to configure your system. And then the last one, Wiring, everything relates to wiring. So these are the 4 main chapters, and then within those chapters we have a lot of sub-chapters as well. So within the first chapter on photovoltaic technologies, we have the first subchapter on the PV effect. So the photovoltaic effect, we'll discuss what it exactly is, and we'll look on the basic operating principle of a solar panel. The second subchapter on materials will look at what kind of materials are available, what the options are, and which options you are likely to go for, so that you understand which options there are. In the third subchapter, we'll look on the improved, so the more advanced kind of solar panels, so the more advanced kind of technologies that are available on the market. And then the last subchapter in the PV technology section, we'll look at the module variation, so what kind of different structures, what kind of physical differences can you find within all the different options of the solar panels available to you. Now that's a general layout of this chapter on PV technologies, so you know what you can expect and you have a kind of a structure that we can use to provide you the information, to share the information with you. So let's start to look on the first one, a PV effect. So the photovoltaic effect is both a physical and a chemical phenomenon whereby both voltage and current is produced. This is really important, remember this. So you're producing both a voltage and a current as a result of the sunlight hitting your solar panel. Now that's just a technical description of how a solar panel works. I find it often most easiest to explain things with a diagram. So let's go to the whiteboard and let me use the whiteboard in order to explain how a solar panel and how a solar cell actually works. And I'm using the word solar cell here because a solar cell are the square or the rectangular blocks that are used in order to build a solar panel. If you zoom into a solar panel, you'll see that a solar panel is actually built of a lot of identical rectangular or square materials that together form the solar panel. Now these solar cells, so the building blocks of the panel, consist entirely of a semiconductor material. It's called a semiconductor because it conducts electricity, but it doesn't conduct it that well, therefore it's called a semiconductor. Now what they're doing in the factory as they're making these solar cells is that they're taking this semiconductor and they alter the chemical properties of the semiconductor, and this is a process referred to as doping. So during the doping process, they are applying a certain chemical treatment to one side of the semiconductor, so that this one side becomes let's say a positively charged side of the semiconductor, but they are applying a different chemical treatment to the other side of the semiconductor, and therefore the other side will become a negatively charged side of the semiconductor. Now the result of these chemical treatments and the effect of now having a positive or a P side and a negative or an N side is that between the positive and negative side in the semiconductor we're getting a very thin boundary layer, which we refer to as the p-n junction. And the p-n junction, this is what it's all about. This is what we're trying to create, and this is where the magic of the PV effect happens. Because if we take this semiconductor with a p-n junction and we hold it in front of the sun, then electrons want to jump from one side to the other side of the semiconductor. They want to jump over the p-n junction inside of the semiconductor, and electrons, which are the building blocks or the driving force behind electricity, they want to jump from one side to the other side, and this then is the start of an electrical circuit. And then in order to use the electricity which is being created over the p-n junction, we connect bus bars. We install bus bars on both the positive and negative side of the semiconductor. and then to these two different bus bars we connect wires, and then we lead the wires, we connect the wires to our load. So your load is the technical term for anything that you intend to consume the electricity, right? It can be an electrical light bulb, an electrical motor, it can be a battery. So anything that consumes the power from your source, from your solar panel, is called your load. So in this way, you are using now the electricity that is being produced by the electrons jumping from one side to the other side. You're taking this power through the bus bars and leading it to your load. So this is how a semiconductor is being converted into a photovoltaic cell, and then by means of the solar power hitting the solar cell, you're creating electricity and you're feeding this to your load, and you've now created an electrical circuit.